just like introducing you guys first of all with the NLTK package. So it is a package that is from a long time has been used for NLP, and it's quite a familiar package. Many of you would be already knowing this package. If not, then it's quite simple to practice and learn, and that's what this workshop is for. So installing this is quite straightforward, just like any Python packages. You just have to do a pip install NLTK on your command line on the system that you are working. And once you are like ready to go for the program, you just have to import the NLTK package. And after that, you have to run this NLTK download command on your console again. So that will also then download some additional packages that we will see in the workshop. That what all exactly are these packages? So basically, like there are different aspects of NLP, the pre-processing steps, one being tokenization, then going ahead, stemming, lemmatization. All these are the basic preliminary pre-processing steps. And we will be going in detail in the subsequent weeks. For example, tokenization, you guys will be introduced in detail in the next week. I think so, yeah, in the next week. So we'll be seeing this in the notebook demo as well, that there's a text object, how this text is used to tokenize. Tokenizing is basically dividing the entire text into words, into characters. So it will be a list of words rather than a whole text as you guys perceive it. So that is a basic token can be understood as a basic word entity that we can use it for further pre-processing. Stemming is like, for example, this example is self-explanatory. If you give in a word, English word, or a word from any language, it will just return you the root word. So there are different packages for stemming as well. One of them is like from NLTK. And if you import stemmer, then from NLTK, then you can use stemmer.stem, and then it will return the root word of that particular word. Now, the problem with NLTK comes is that um, there are some words that it returns the root, which does not belong to the dictionary. That is, it is not actually an English word. So for that comes lemmatizing. So lemmatizing, to its furthest extent, makes sure that the root word that it returns exists in the dictionary. That is, it is actually a word. So for example, beliefs, then it will return belief. Belief is the actual root word. Then there is something known as stop words, which I will introduce you in the demo. So I will go through that in detail. So yes, switching to the notebook. You guys can follow along if you have the notebook with along with you. You guys can just open your notebook and or see on my screen, whichever way works best for you. Yes. So as I told that first you have to install NLTK and then import NLTK. So I'm doing this in a notebook format, as I will be showing you some graphs and analysis. So it becomes much more convenient to show in a notebook format. It's kind of more interactive. Okay. Is this size sufficient to you guys, by the way?
Can I have a question?
Yeah, sure. Go ahead.
Yeah, I was trying to open or download this workshop. I mean, this workbook, but then
Okay.
I don't know why. Every time I try to open, it show up a message like application, something like that, searching application.
So are you not able to download it?
I'm not able to download the workbook along with the practice.
Okay. Okay. I'll let you know about that after this workshop.
Sure, thank
Yeah.
you.
As of now, in this workshop, you guys can ask me questions in the chat box regarding this. And if there are some different types of questions, then we can address those on Piazza.
Okay.
Yeah. All right. So yeah, so this is here where you import the NLTK package. And this showed you in the slides like NLTK.download. So what you guys have to do in the console is just type in NLTK.download without the argument. Like over here, I have provided the argument. So this is because I am showing you on Colab, Google Colab. It's a cloud platform. So that's why I'm only downloading the packages on an ad hoc basis, the packages that I will be requiring. But what you can do is that you can download all in once. So a dialog box will appear to you guys, and there's an option to select all. It will take a couple of minutes, and all the packages will get downloaded. So once that is done, NLTK, we can go ahead. So NLTK contains a text object. So from NLTK.text, I have imported a text object. Now what that does is, first of all, like there's a, I don't know if you guys know about the Gutenberg project. So after this workshop, maybe you guys can just search it on web. It contains a lot of free books, like archived old books that you can read online free or download it as text. There are various download options. So NLTK provides an API where you can directly interact with the Gutenberg projects, the books. So this is how you, this is the API and this is how you interact with it. It is nltk.corpus.gutenbergs.words, .gutenbergs. And over here, I'm selecting this Alice in the Wonderland book. So it is carolalice.txt. So for this reason, I have downloaded this nltk.download Gutenberg. Now .words provides you the tokens that I had shown you the slide tokenization step. So this is basically the tokenization step where you will get all the words. And this text object is just wrapping these words in a NLTK text object. So what is the use of this? That I'll show you in the subsequent steps. So, and this I have assigned to a variable Alice. Now, before going forward to the about this variable and about this text object, you can see what are the all the different books that are available in Gutenberg project by just doing Gutenberg.field IDs. So these are the different books. Like you guys can choose any book that you want. If you guys are interested in Bible, instead of Alice, you have to just put the Bible text. We have chosen the carolalice.txt. So now going about this Alice variable that I have saved. So as I told that it's like an NLTK text object. So if you print the type of this object, it is class NLTK.text. And the one good thing about this is that it's very Pythonic. So by that, I mean, it just works like a normal list. So if you guys have worked with Python's list, it is very much similar to that. So I can just print the length and it gives me the total word count. So it's around 34K. Now accessing, just like you access the list by subsetting, subslicing, it's done in a similar way. So suppose I want to see the contents, I can just do Alice, and if I want the first four characters, it returns me this. If you want to see the entire list, I just remove 4 from here, put a colon. It will give you from start to end. So I have not done this because it will populate my entire screen. So that's why I just, for an example, shown you the first 4 words. So it's in bracket, Alice. That would be the heading of the book, maybe. So this is it. Now, there are many different things that you can do. For example, a unique word count. So this returned you the total word count. So as I said, it's very much similar to a Python list. Just put set operation over the list, and it will give you the unique words in a set. Similarly, you can do the count on how many times a specific word occurs. So these are actually not just for NLTK object. It's common to any Python list or strings. So alice.count Alice. So it will give you that Alice word has been used 396 times in here. Now we can check in something that is more specific to NLP, more specific to NLTK package. For example, this terminology of concordance. So over here, it will not just show the total count of how many times Alice has occurred, but also in what context. So in which all sentences does Alice word has occurred. So these are the matches. And then there are various other plots that you can make, like a dispersion plot, for example. So over here, this is on the y-axis is the words that I have chosen, like on which areas does these words occur, like in which part of the books does these words occur. And on the x-axis is the total, like entire length of the book. So you can see that Alice word occurs quite uniformly throughout the book. So these are some interesting analyses that you can do. So as data science students like you guys want to do some analysis. So these are just the various ways. So I'm just introducing you guys to some of these things. So it will get easier for you to head start on this. For example, the word rabbit, it occurs in some parts in the beginning, then at the end. The queen, if you guys have read the book, then the queen character enters maybe from around half of the book. So you can see that this occurs after the midpoint. So these are some interesting plots that you can make. And this and that is the reason why I did a wrapping around the NLTK text. As I mentioned here, I have wrapped it around text object. So this text object supports many plots. For example, this concordance thing, this plot that I just showed you. So it becomes convenient if you are using that text object, NLTK text object. Now, one interesting thing is the frequency distribution. Like, what is the frequency of each word that occurs in the text? That's quite interesting, right? Like, if you want to see the frequency of the entire corpus of the text that you are analyzing. So, NLTK dot FREQ dist stands for frequency distribution, and you pass in the text object, and so we stored it in the fdist variable. And now if you print it, it will be kind of a dictionary. I don't know if you guys have dealt with it, but you guys can, after this workshop, deal with the dictionary data structure of Python. So it is basically a hash map, and this variable basically stores this frequency distribution as a dictionary. So one column will be the word, and the next will be the count. So for example, if you want to plot it, we can simply do fdist.plot and the 50 most common words. And here I'm putting cumulative as true. So this is the kind of words that you get, see, quote, the, and these are the respective cumulative counts. If you don't want to have a cumulative count, but a hard count of each word, then you just don't put the cumulative equals to true argument. And you see that the quote is the most important thing in the text. Then comes the, then comes and so on. But from these plots, you guys can realize that it consists some things that is not very useful to us. For example, the punctuation marks. You guys would not be very much interested in the punctuations. So how about we remove the punctuations and then see the frequency distribution, the distribution of the words. So we can do this from, and again, we wrap it around NLTK.frequency distribution, but basically we are using the fdist variable that we have defined earlier. That is this variable. So as I had mentioned, it is a dictionary. You get the key value pairs from a dictionary by this fdist.items. If this syntax is not very familiar to you, you can have a look at how a dictionary is operated in Python. How do you access its key values pairs? So this is the word and frequency that we have fetched from fdist.items. And here we are putting a condition check. That is, the word should be is alpha. Now it is a common Python dot is alpha is a Python inbuilt function for string, whether it that checks that whether that string is alphanumeric. So only if it is alphabetic, then it will be returned and stored in the dictionary, and wrap it around this frequency, this package frequent dist. Again, we are packaging, wrapping it around this so that we can do the plot over here. So I have just used a different variable name, that is fdist, but with no punctuation. And I've plotted it. Then you see there are no punctuations on the x-axis. Now, how can you further optimize it? You see that the first word is the, then comes and, to. Now, these are very basic words. These words are what is known as stop words. So, as I had shown you in the slide and told you that I'll show you in more detail in the notebook. So, These stop words are words that are not very important for analysis. So for example, as I've shown, the, I, me, myself. So you can get this from stop words function in NLTK. So again, I have used the NLTK.download, but you guys need not do it if you have already downloaded all the packages all in once. So here is how I yes, so here is how I define a variable stopwords, and it is nltk.corpus.stopwords.words, and the language of stopwords should be English because we are dealing with English. There are different languages that are supported in NLTK. So this will provide me with the list of all English stopwords. So there are a lot. So just to give you a zest, I have shown you the first 5 words, and this is how you access, just like a list. So it is I, me, myself, we, these kind of common pronouns and conjunctions like and, the, these all are stopwords which should be included in the list. So you guys could have guessed the logic, what is the motive behind this. So instead of just removing the punctuations from this graph, now I will be removing the stop words as well. So it's the same syntax that we had dealt earlier. Just instead of just putting one check, that is word.isAlpha, we are putting another check. This is important, not in stop words. So now in the if clause, we are putting 2 checks that the word should not be in stop words and it should be isAlpha. That is, it should be alphanumeric. And now again, I store it as a variable of no punctuation and no stop words. And when I plot this, now this plot will be much more meaningful, as the words won't consist of words like common words. So it contains Alice. Alice is, you can see, in one of the most frequent words, though the x-axis is not very visible over here, but yeah. So this was regarding some preliminary analysis. So moving ahead, there is some terminologies associated with NLP, one of them being like hepaxis. So you can check it in Wikipedia what it means. So it is like, what do we say? The words that actually occur only once in the entire text. So like whole, conversations, daisy. So if I do a fdis.hepaxis, it will print all the words that actually just existed once in the entire text. Then there is something known as collocations. So collocations is basically 2 words that are mostly used in conjunction with each other, juxtaposed with each other. For example, like red wine. So something like that. So if I do that, alice.collocations, it will return all the collocation exists. For example, the white rabbit, it is a famous character, so it returns white rabbit because it has been used together quite a while quite many times in the text. And Alice, just to make you remember, is the text object that we had created. So moving on, like there are different ways by which you can access the Gutenberg data. So this is what we had done earlier. This is not new, just I have redefined it in a different variable name as Alice words. It's the same as Alice over here. Only thing is that I have not wrapped it around the NLTK text object. So it's the same. So like if you print Alice words, it will consist of all the words in the text. Now Python by default doesn't show all the uh, entries of the list for the same reason that it will populate my screen. But you can see the length of it, like it's the same 34K around. Now, this is how we had fetched the words. Now, what if you want to fetch the characters? So if I fetch all the you can fetch all the characters by, instead of using Gutenberg.words, like over here we had used Gutenberg.words. Over here I use Gutenberg.raw over this Alice text. Now this gives me the entire characters. So if I see print out Alice characters, it will give me the entire characters of the book. This. So this is quite huge. Similarly, we got words, we got characters, now come sentences. So just instead of words and raw, you will use cents to get the list of sentences that is in this text. And we define it with another variable as Alice cents. Now, when we got the all this Alice sentences, words, and text, we can do some analysis on it, some preliminary stats on it. For example, suppose I want to get a average word length. So we can get that by total number of characters by total number of words. So that will be average word length, right? So we had stored the total number of characters, all the characters in Alice chars variable, and when I do the length of it, it gives me total number. Similarly for words, and you will see that the average word length is 4. Similarly, we can do average sentence length, that is the total number of words by the total number of sentences in this entire Alice in the Wonderland text. And we get 20 as the average sentence length. So in this cell, I have just used the above two lines that I used to calculate word length and sentence length. I've written them in functions. So average word length and return the same as we had calculated over here. I've just generalized it. So for just not for Alice, but for anything that you do, we will give it two arguments, the number of characters, the number of words, and it will return the average word length, and similarly for average sentence. So same as above, but just I have more generalized it and written in a function. So why have I done this? I have done so that not just Alice, but as I had mentioned, there are different books that is in Gutenberg. So instead of just the Alice in the Wonderland book, we can iterate over all the field IDs that are there. So I had shown you the field IDs that were different books. So over here you can see that for field ID in the entire list of field IDs, I collect the number of characters, then I collect the number of words, and I collect the number of sentences, just like we had done previously. For characters raw, for words we have used words, keyword, and so on. And then I have printed the file ID, the average word length. How is the word length calculated? As I had written this word length function, and similarly the sentence length function, and printed all of that. So over here you can see the first, since it iterated to the first file ID, that is Austin Emma, it contains a word length of 4, average word length, and average sentence length of 24. Similarly, it has done this for all of the field IDs that is available in the project Gutenberg. One interesting thing to note is that you can see that the average word length is 4 for all, but for the sentence length varies. Now moving forward, um, the one thing that I mentioned over about the project Gutenberg here was that there are actually a lot of books that is there, but it is not provided with the NLTK library. So if you want to generalize the accessing of data that is accessing, there is some other way by providing in the URL. So for example, I want to analyze something on the Oscar Wilde book. So this is the URL. So this is not something specific to NLP. This is something from Python. You have to get this URL open library and import it in this way, and then just access that URL. So it's like you read that URL and decode it to UTF-8 so that you can see and it can get decoded in the correct language. So when I print in raw, this is what is the contents of the book, the Oscar Wilde book, since it's a URL of that book. Now it's a quite a humongous corpus of characters. As you can see, if I point it over here, there's a lot of characters. It just shows some of them. Now, if you want to do some NLTK processing on, some NLP processing on it, just like previously we have done, we wrap it around nltk.text. And what will be the argument? Raw. So this is the variable that we had fetched from URL, and we just wrap it around the NLTK library. And these are the things that we had done earlier. For example, the frequency distribution, just like we had done but for Alice. So like you can do it for different things. So that's what the motive of this is. So we can move on to some another corpus, that is the word text. So here I have downloaded word text. Now, sorry, web text. Now web text has different field IDs. You can iterate over these field IDs. Web text, you can just have a look in this GitHub account that shows the different file IDs, Firefox, Grail. These are the different text corpuses. So you can just have a look on these. And this is the similar things that we have done earlier. Remember, like calculated the number of uh, words, number of characters. So instead of Alice, we have used the Grail file ID over here, the Grail one, and got all the necessary word length, character length, sentence length. And then we have called the function that we had defined earlier, the average word length, average sentence length. So I'm just skipping this because this is kind of repetitive and we have already done this. Now something interesting, I will move on to some different another corpus, that is the inaugural corpus. And here I'll just do a small but quite an interesting exercise for you guys. So this is the address corpus that I have chosen. So in inaugural, there are different file IDs, just like there was Gutenberg. This is inaugural, and I just print out the different file IDs. So this is basically the different presidential inaugural addresses that all the presidents have started with in their term. So starting from 1789 to 2017 by Trump. So this is all the inaugural addresses by these presidents. So it has not yet been updated. The last time I checked, it has not yet been updated. Maybe you guys can check, and it might have been updated by with next president Biden. So as of now, it's just Trump, till Trump 2017. So you can see the format. It's the year followed by the president name.txt. That is the file ID name. So let's do some interesting thing over here. Suppose I want to see that in all these president inaugural speeches, how many times have they used the word America? And not just America, but anything related to America, like Americans, American, America. So let's do this analysis. Like in every inaugural speech, how many times this word has been used. So this is quite a nested for loop that we use. So for file ID in inaugural file IDs, so that is it will iterate through all the file IDs in the outer loop. And here we make an America count. We initialize it with 0. And then there's a nested for loop. For each file ID, we will iterate over the entire words. So here I have done words, like this is all like we have already done that in Alice, right? So this is just an exercise using those things. And for every, W represents the each word. So here what I do is if W dot lower, this is just to generalize so that it doesn't misses out America with a capital A. So I have generalized it with W dot lower. Dot starts with is a Python function for any Python string. America. So even if it's American, it will catch that. Even if it's Americans, it will catch that. Only criteria that it should start with America. And if it comes across such a word, the count is incremented to 1. And so on, the variable America count will contain the total count for each file ID. And when it moves on to different file ID, like in the outer for loop, it will refresh it with 0. So this count has been stored, and then I will just print it out. So for that, I've stored the president name in the variable president, the year in the variable year, and how I have fetched that from the file ID, and then print it. So you can see President Washington of year 1789 said America 2 times. The next, again, the same president said 1 time. But just by just looking at this simple exercise, you can see as time progresses, maybe the presidents have become more patriot and they have used America like more number of times. And you can see that Trump has said America the maximum number of times, 35 times. So this was quite an interesting yet a very easy analysis, right? Okay, so we are running out of time, so I'll just quickly show you the last exercise. It's just built on the same lines. It's just that as you see that if the corpus is quite large and if you are doing analysis on different conditions, then instead of printing out texts like this, it is more convenient if you can visualize it. And as data scientists, visualization is a very common aid that you will come across in your day-to-day fields. So just it's it's the same approach that I have done in this exercise. Instead of America, I'm also searching for citizens. That how many times the presidents have used the word citizen and how many times they have used the word America. So just the same, it's just syntaxically a bit different because I'm wrapping it around conditional frequency distribution. That is just like frequency distribution. You guys had used frequency distribution NLTK package. It offers another package called conditional frequency distribution. The condition here being that we will be searching for the words America and citizen. So it accepts a pair of lists. One is the target, which is the conditions, that is America and citizen. And the next is the file ID. So for that particular file, and it's the same for loop that we have written over here. It's just written in a more systemized way. So for the outer loop is the file ID, the inner loop is the words, and similar to that, we get all the words of America and citizens. Starts with the target. There we did America because it was just one word. Here we're doing target because it consists of two words. And we have stored this in a CFT variable, and then we have plotted this. So if you look at this plot closely, it's yeah, right. It's the blue line represents America and the orange line represents citizen. So you can see that in between, and though the x-axis is not visible, but it is the samples that the different precedents, the different file IDs. So you can see in beginning in mid there is a spike of citizen. Like this particular president has used the word citizens a lot, and even America is respective to Americans as a spike. And you can see that in the end, like Trump had used the word America a lot. So there's another spike over here.